Hello everyone, I am Rahul Kumar Singh presenting a paper on the topic Investigation of Diesel Engine Combustion Characteristics for Varying Nozzle Depth at Different Spray Angle. My article number is 1440. These are the key points of this paper. The need of petroleum fuel is increasing every day, which produce major harmful effect on the environment. The need of petroleum fuel is increased simultaneously with its price in the market. Researchers around the world are focusing to reduce the harmful effect of petroleum fuel. The present research is about the reduction of harmful gases from the exhaust of the diesel engine. This research also includes the detailed analysis of the combustion performance parameter. A Kirloskar single-cylinder engine of model TB1 is selected for the numerical simulation for this research using a commercial available software which known as AVL Fire. The further process with the selection of three different spray angle like 120 degree, 140 degree and 160 degree, in which 120 degree is standard spray angle for the Kirloskar single cylinder diesel engine. Analysis the effect of nozzle depth on the combustion parameter. The four nozzle depth are 0.5 mm, 1 mm, 1.5 mm, 2 mm, in which the 1 mm is standard for the Kirloskar single cylinder diesel engine. All four nozzle depth are examined under the 120 degree spray angle, 140 degree spray angle and 160 degree spray angle. To get the suitable combustion and emission result, some compromise has been considered for the performance parameter. This is the introduction. The modern diesel engine developed is governed by maximum efficiency at low emission requirement. The variation in the spray angle at different nozzle depth has enhanced in engine efficiency and decreased emission by improving the automation characteristics of the fuel spray. The experimental investigation of diesel spray angle and diesel nozzle depth are very challenging due to the major modification in the engine from its standard condition. Hence, we are use a suitable software for getting the result from the variation in the engine operating condition. The nozzle depth and spray angle can be changed by means of the inbuilt mechanical system. Many researchers claim that the most part of the entire pollution of the is from the emission from the CI engine. As per their research, the control of emission seems to be possible way to reduce pollution from the environment. Based on the history of emission control, the following method are potential to reduce the emission from the diesel engine. The enhance of air-fuel mixture due to the change in design of piston geometry lead to improved combustion process and reduce emission parameters. The air-fuel mixture is also affected by the swirl method to reduce the emission from the engine. The optimization in spray parameters is helpful to better combustion process because of enhance of air-fuel mixture. Emission can also be reduced by using exhaust gas circulation method in the CI engine. The most popular method in the present scenario is to use biofuel gases blended with the diesel to reduce emission from the diesel engine. The motivation of the present research is gained by the keeping the mention M in the mind. The combustion characteristic will be analyzed numerically for the single cylinder Kirloskar diesel engine in a varying nozzle depth at different spray angle. Engine is an interesting area for the research. The emission is governing factor which affected whole the engine and produce power. Every fuel in the world is used to produce certain amount of emission by either mechanically or chemically process. The objective of this work as following. The nozzle depth will be changed from 0.5 mm to 2 mm and spray angle will be changed from 120 degree to the 160 degree. The optimum nozzle depth and spray angle will be founded by analyzing the combustion characteristics of engine. Commercially available simulation software which is used for the numerical simulation. The present research illustrate that the effect of variation in nozzle depth at different spray angle on Kirloskar single cylinder diesel engine. The researchers all around the world are trying to reduce heat loss from the CI engine. Thus is required more attention to analyze the heat balance at varying nozzle depth at different spray angle engine and to check their effect on thermal efficiency and power. There is need to explore the optimum nozzle depth and optimum spray angle on which engine gives the best result in form of emission and combustion. Research methodology. The commercially available numerical simulation software, which known as AVL Fire, is used for the research. Present research work consists of numerical simulation approach for the optimization of spray angle, and spray angle are categorized into three cases to achieve an optimum case. Furthermore, for more nozzle depth parameter are also categorized under each case of spray angle. At the end of analysis, the combustion of spray angle and nozzle depth are examined for the satisfactory outcome of research. The research methodology can be present in the following flow diagram. Firstly, numerical simulation is done by selected spray angle. There are three spray angle which we obtained: 120 degree spray angle, 140 degree and 160 degree spray angle. In the selected spray angle, in each spray angle we will select 4 nozzle depth: 0.5 mm, 1 mm, 1.5 mm, 2 mm, and after that we get the optimum case in term of combustion and emission. Specification of simulation diesel engine. A single cylinder diesel engine model TB1 was used to simulate simulation purpose. This engine has a hemispherical piston blow geometry with standard spray angle 120 degree and standard nozzle depth is 1 mm. The parameter regarding engine geometry and working condition are mentioned in many references by researchers. Some of the important design parameters are shown in table. Maker of this engine is Kirloskar, model TB1, number of cylinder is 1, bore 87.5 mm to 110 mm, shaft volume 661 cc, clearance volume 40.1 cc, number of nozzle hole 3, connecting rod length 234 mm, rated output 5.2 kilowatt, cylinder head curvature is flat, peak pressure 72 to 76 bar, clearance 0.112 centimeter, which is equal to 1.2 mm. Types of combustion is hemispherical. Types of chamber: open combustion chamber. Rated speed 1500 rpm. Compression ratio is 17.5:1. Initial boundary condition of Kirloskar diesel engine. Initial boundary condition in which initial pressure is 0.65 megapascal, initial temperature 300 Kelvin, piston temperature 550 Kelvin, linear temperature 425 Kelvin, head temperature 475 Kelvin, fuel spray angle 120 degree, solid angle, cone angle, injection type single injection, mass of fuel injection 1.6 to 5 kg per cycle, nozzle depth 1 mm, which already explained in the previous slide. Conclusion. The following conclusion are obtained from the above result which are given. The maximum mean pressure is observed at 160 degree spray angle and 2 mm nozzle depth, and the value of maximum mean pressure is 6061253 pascal, and the minimum value of mean pressure is at 120 degree spray angle and 0.5 mm nozzle depth, and the minimum value of mean pressure is observed at 540,125 pascal, and the percentage of change of mean pressure from minimum value to maximum value is 12%. The maximum mean temperature is observed at 160 degree spray angle and 160 degree spray angle and 2 mm nozzle depth. The value of maximum mean temperature is 730.516 Kelvin, and the minimum value of mean temperature is obtained at 120 degree spray angle and 0.5 mm nozzle depth, which is the value of minimum mean temperature is 1563.31 Kelvin, and the percentage of increase in minimum mean temperature from the minimum value to maximum value is 10%. The maximum heat release rate is observed 160 degree spray angle at 2 mm nozzle depth, and the maximum value of HHR is 17.83 joule per degree, and the minimum value of HHR is obtained at 120 degree spray angle and 0.5 mm nozzle depth, and the value of minimum HHR is 13.25 joule, 13.3251 joule per degree. The percentage of change increase in HHR from minimum value to maximum value is 33%. The result reverted that the combustion parameter depending on the spray angle and nozzle depth. By analyzing the above case, it can be conclude that the 160-degree spray angle and 2 mm nozzle depth is give the best optimum result for the combustion parameter. However, to get the suitable emission result from the above case, some compromise consider. These are the reference which is used in this paper for the completion of this research. Thank you.